Good evening, and welcome to this evening's Caring for Creation webinar, the seventh and last in our current series of forums. If you missed earlier sessions, you can view them on the Caring for Creation page of Bethel's website. And stay tuned, since there are more events coming just a little later this year. More on that later. In a moment, we'll welcome tonight's guest speaker, Dr. Steve Vavros of the Nelson Institute for Climatic Research at the University of Wisconsin-Madison. First, though, please take an active part in tonight's event by submitting questions and comments during Steve's presentation. It's easy. Just type your question or comment using the chat feature of Zoom. On my laptop screen, there is a chat button to click at the bottom center of the screen. On an iPad, the chat button is probably in the upper right corner. When you click the chat button, please select the option to send your comment or question to all panelists and attendees so that we all see it. And don't forget to click the Enter key. We'll compile your questions and comments for discussion after the talk. Tonight's webinar was originally arranged as an in-person event last year by our beloved John Kutzbach, one of the founders of Bethel's Caring for Creation group and the longtime director of the Nelson Institute Center for Climatic Research. John would have chaired this session, but his death in January of this year deprives us of his presence, except in spirit. So we've asked John's and Steve's colleague, Professor Dan Vimont, to step in and introduce our speaker and to moderate the discussion session after the presentation. Dan?
Thanks, Todd. And thanks everyone for attending today. My name is Dan Vimont. I'm the director of the Nelson Institute Center for Climatic Research. And I'm very pleased to introduce our speaker, Dr. Steve Vavros, today, and to help moderate our discussion after his talk. Before the introduction, though, I want to take a moment to remember John Kutzbach, who was a longtime parishioner at Bethel Lutheran and I believe helped found the Caring for Creation series. As you may know, or as you do know, John passed away in January. In my career at University of Wisconsin, I've had the honor of working with wonderful friends, people who are great parents, who are loving husbands and wives, or wonderful family members, and who also happen to be world-renowned scientists. John exemplified this in his career. I want to tell a quick story about when I first met John. I was a graduate student and I was aware of his name, but my research was slightly different than what he did. And so I wasn't fully aware of the research, of the extent of his research. And I was interviewing here for a faculty position. I sat down with John and John asked me, Dan, have you thought about any other areas of research you might be interested in pursuing? And I thoughtfully looked back at him and said, I don't think anyone has really addressed the issue of the, I'm sorry, I'm sorry, I'm afraid that my computer has frozen up here. Can someone write in the chat bar and, okay, I'm sorry. John looked at me and said, have you thought of any other areas of research you might be interested in pursuing? And I looked at him and said, I don't think anyone has really addressed the issue of the wet Sahara in the mid-Holocene. And I think, someone ought to take a really good look at that. Now, if I were to say this at a major conference, that statement would be followed by gasps and groans, because as everyone knows, this was a major area of research for John. John, not only was it a major area of research, but John was a very decorated scientist. John had received the top medal in the American Geophysical Union, the Roger Revelle Medal, the Milankovitch Medal for the European Geophysical Union, the Humboldt Research Award, the top award that can be given to an international award given in China, the International Science and Technology Award of China in 2017. And in 2006, John was elected a member of the National Academies of Science the highest honor that can be bestowed on a US scientist. And as I looked at him and told him that, I don't think anyone's really addressed this issue, John kind of looked at me in a way that, and he kind of pursed his lips and looked at me and said, we've written a couple of papers on that issue, in a very humble way. I thought that was the last time I would ever be in Madison, but a couple of weeks later, I received an offer, and my wife and I were back in Madison visiting and having dinner with the Coots Box, where I had the opportunity to meet Gisela and to realize what a wonderful family and what a wonderful person both John and Gisela are. It's been I had an opportunity to speak with John before he passed, and he spoke with excitement of the research, of new research in climate sciences, and new research that was going on at the university, especially the research that was happening with translating information about climate change into real action here in Wisconsin. That's a perfect segue to our current speaker, Steve Vavros. Steve Vavros was John's last graduate student and currently directs the Wisconsin Initiative on Climate Change Impacts. Steve received his PhD in 1997 and his master's degree as well at the University of Wisconsin, and a bachelor's degree at Purdue University, but we won't hold that against him. Steve's work is nationally and internationally recognized for his contributions to understanding fundamental processes that govern a wide range of topics in climate sciences, including Arctic climate, extreme weather, the origin of human impact on climate from 4,000 years ago to present, local climate change, and working with people around the state to understand the impacts of climate change. Steve currently co-directs WICI, the Wisconsin Initiative on Climate Change Impacts, which is a perfect position for his varied expertise and his outstanding skill working across disciplines and organizations. With WICI, Steve works with scientists, policymakers, practitioners, and educators around the state to advance the understanding of climate change and to help develop solutions for addressing the causes and impacts in our state. Steve is my go-to resource when I have questions about extreme events or local climatic events. And like John, Steve's just an outstanding person. So it's my distinct pleasure to be able to introduce Steve Vavros today.
Well, thank you so much, Dan, for that very kind introduction, and to Bethel for the invitation. I was more than happy to accept when John brought it up over a year ago, thinking it was going to be a live event, but the pandemic certainly put an end to that. So this has been a long time coming, and I'm really happy to be here finally tonight, even if virtually, to talk to you. So I'm going to get into the presentation here. I'll start sharing my screen. All right, and just to make sure, is everyone seeing the slide okay?
Looks good.
Good. Okay, so I want to say first, I feel always a sense of responsibility as being John's final student. I always feel like I pushed him into retirement. I hope that was just coincidental, but there's always a part of me that wonders, did I push him over the edge there? Anyway, obviously climate change was a topic near and dear to John, as was extreme weather and his breadth of intellectual curiosity. And so I'm merging these two in the presentation tonight. As we heard, John was the longtime director of the Center for Climatic Research. He was the director when I arrived back in 1990 as an interested graduate student. And basically, CCR is all about trying to understand climate better and use this information for societally relevant purposes. And that's always been the mission, covering past, present, and future climates. John touched on all of these, and in my current research, I've also dabbled with all three of these as well. And it's hard to think of something that's more societally relevant right now than climate change and extreme weather. And you shouldn't just listen to a biased climatologist like me saying that. We can look to another source. In this example here, the World Economic Forum, which puts together reports periodically. And in 2016, they listed the top global risks. And they listed it in terms of likelihood from less to more on the x-axis and impact from less to more on the y-axis. And notice that almost at the very, very top here was failure to address climate change as the biggest global risk. And then also high on the list, especially for likelihood, is extreme weather events. So both of these are considered extremely important topics as well as being very high risks. And it won't come as news to anyone probably that we can't seem to go a month without some major headline blaring at us about the latest extreme weather event. This collage I put together of events that have happened just in the past year. Just a reminder, last summer we had this big Siberian heat wave when it reached 100 degrees north of the Arctic Circle. The big Texas power outage, cold wave, snowstorm, whatever you want to call it, was a big deal here in February. Last summer, again, we had so many Atlantic hurricanes making landfall, we ran out of letters of the alphabet to name them. But at the same time, at the other end of the spectrum, we had such hot, dry weather out west that we had these terrible wildfires, as you'll recall. And close to home, the derecho or windstorm that hit Iowa and clipped southern Wisconsin was the most costly thunderstorm disaster in American history. So in addition to these extreme weather events being very disruptive, they're also deadly. This is a listing from the National Weather Service of annual fatalities from extreme weather in the country. The type of events is shown at the bottom: flood, lightning, tornado, hurricane, and the like. I want you to focus on the yellow bars. That's the most recent 30-year averages. And notice that it's heat. Extreme heat kills more Americans than any other weather disaster, followed by flooding. And the others farther down on the list. In addition to being deadly, these extreme weather events are also very costly. And they're also getting more and more costly. This graph shows the number of billion-dollar weather disasters in the US over the last 4 decades. Each bar represents the number of the events, and the color coding lists the type of weather event. And this has all been adjusted for inflation. And notice, if you just eyeball it real casually, you notice there's been an uptick, and especially in the past decade. Some near record highs, and then last year, the very all-time record high, $22 billion weather disasters in the US, which easily broke the record set a few years before. So not only was 2020 a really bad year for public health and the economy, but Mother Nature didn't help out either and caused a lot of problems in the US and elsewhere in the world. Now, you might say, well, maybe we've just made ourselves more vulnerable to extreme weather. Maybe that's why they're getting more costly. If you build a high-rise condo in a hurricane alley, you're going to pay for it eventually. But we can actually extract what the extreme weather contribution itself is to that trend that I just showed by showing something called the Climate Extremes Index. This is put together by NOAA, National Weather Service, and it's a compilation of extreme weather events across the country in terms of extreme heat, cold, extreme wet, extreme dry, and the like. And they calculate what percentage of the country experienced such extreme weather in a given year. The baseline is 20% coverage. And you can see going back all the way to 1910, so we have more than a century of record here. You see a lot of year-to-year variability, just the vagaries of weather, but then you notice this long-term upward trend toward the present. And you can see that a little more clearly if you look at that green line. That curve represents the running average. And that's been above this baseline amount over the last 15 years consistently. And you see these record and near record highs recently. Last year was the 7th highest on record. So it's not our imagination that it seems like extreme weather is becoming more common. And we know from this graph that the primary contributors are extremely heavy short-term rainfalls and extremely warm nighttime temperatures, particularly in the summer. In a talk like this, you really need to get down to some basics, some terminology. What is weather versus climate? And that question comes up in a talk about climate change and extreme weather. So I've shown this photo here, presented this to you, and it comes with a story. About 15 years ago, I attended the American Meteorological Society annual conference in San Antonio in January. And it was an interesting time to be there because a massive ice storm hit southern Texas. And you can imagine how that would shut down San Antonio. But the hotel where the conference was held was still open, and I got together with a fellow meteorologist friend for lunch. And we were looking out the window, and we saw a scene a lot like this one. And my friend made a great observation. He said, you know, that picture perfectly encapsulates the difference between weather and climate. He said that palm tree is there for climatic reasons. It's usually warm enough in San Antonio to support palm trees. But weather has crept up today, and even in a warm climate like San Antonio, you can have an extreme weather event short term that causes a palm tree to be encased in ice. And so that story always stuck with me, and I thought it was a nice imagery to make this distinction for this talk. Now, in reality, the lines between weather and climate can get blurred, particularly in a presentation like this when we're talking about extreme weather and how it may relate to climate change. For sure, we know that the climate is changing, and we're setting near record or record high temperatures year after year. Another headline here from the New York Times from 2016, Earth sets a new global temperature record for the third straight year, and it hasn't cooled much since then. 2017 was the third warmest year on record, 2018 the fourth warmest, 2019 the second warmest, and then depending on which data set you believe, last year was either the warmest or the second warmest year on record. Clearly, when we're getting these kind of extremes in heat, it's no longer just by chance, it's no longer a fluke. The climate truly is changing. And to put this into perspective, it's better to look not just at the annual average temperature like that over the past decade or so, but we can actually look back over 140 years and see what the spatial patterns have done since then. And this is an animation put together by NASA that shows the evolution of global warming since reliable temperature records began in the 1880s. And what's shown here are the warm colors in yellow, orange, and red representing warmer than the long-term average, and the blue cold colors representing cooler than normal years. And these are all averaged over 5 years, kind of a running mean. And I'll put this into motion and you'll be able to see that by color, the warming climate. So in the 1880s, you see lots and lots of blue, some occasional yellows, maybe an orange, but generally a pretty blue globe indicating cooler than the long-term average. Then we get into the 30s and the Dust Bowl, cool off again mid-century, quite a bit of blues in the 60s. But notice in the late 1970s, right about here, everything starts to warm. It's lots of yellows, get oranges and reds, until finally, when the animation ends here, we see the world awash in these warm colors. And it's not the same everywhere. The Arctic up here, warming twice as fast as the globe as a whole because of the loss of the chilling snow and ice cover. You also notice that land is warming more than the oceans, Eurasia in particular, but really you're hard pressed to find any place on Earth, on land at least, where the Earth hasn't warmed considerably over this time period. So that gives us a good sense that we're not alone. Everybody's more or less participating in this warming climate. We'll end that. And we also know the reason for this warming trend. I imagine just about everybody in the audience knows that we've been pumping in all these heat trapping gases for a long time, primarily industrialization, also agriculture. And I'm going to show a different way of presenting that right now. Most of us have seen these graphs showing carbon dioxide going up year by year, and that's important. But I came across this graphic from the Washington Post a couple months ago, and I thought it was really impressive for a way of looking at this. So what this is showing is not the actual CO2 in the atmosphere, but the changes within each millennium. And there's lots and lots of millennia here. This is going back 800,000 years. Using air bubbles trapped in ice cores from polar regions, we can actually see how high the CO2 or methane concentration was going back in time. And what you see is that in most of these ancient millennia, before humans became a dominating part of the climate system, these fluctuations were small. They were typically 10 parts per million plus or minus over an entire millennia, sometimes even less than that. For perspective, we're at over 400 parts per million right now, so this represents a very small amount. So that's sort of the natural record of fluctuations. And now this is what's happened in the last millennium. It just takes your breath away how much humans have altered at least the atmospheric composition in the past millennium, completely blowing away the natural variability. And what maybe is just as striking is that the vast majority of this in the last millennium has happened just in the last 100 years, showing the dramatic impact of industrialization. And when you put these heat trapping gases in the atmosphere, it stands to reason that the climate would warm, just as we've seen. Now, that's the big picture, global picture over many years. Around Wisconsin, we've certainly experienced a warmer climate as well, and it's also been getting wetter. We have records going back about as far as the global network that I just showed, in this case from the 1890s. And what I'm showing here on the left is the long-term record of Wisconsin's temperature averaged by decade to smooth out some of the year-to-year noise variations. And on the right is the same figure for precipitation amount, statewide averages. And what you see, again, I like just eyeball these things at first, you definitely see a warming trend with some decade by decade variability. You can pick up the warm Dust Bowl years of the 1930s, but even they weren't as warm as the last 2 decades since the turn of the 21st century. Those have been the warmest 2 statewide. We also see an upward trend in precipitation, although it's not as steady as temperature. What we really notice is that the last decade was remarkably wet. It set a record by far, about 10% higher than any previous decade. And for good measure, the final year of that decade, 2019, was the wettest year on record. So definitely warmer and wetter are the key words to describe our Wisconsin climate change going back more than a century. It's not only the averages that I just showed, but it's the extremes. And that's what we really notice, and that's what has a disproportionate impact. I'm showing here a figure borrowed from Dan Weimont of 100-year daily rainfalls during the past decade. And so these are events you would expect to happen only on average once every 100 years, but in fact, Wisconsin's seen at least 20 such events, affecting just about every major part of Wisconsin, except for possibly the very interior, but just about every sector of the state has been affected. And the biggest of all, right here in Dane County, which I'll get into next, the highest total of all. We're not alone, for better or for worse. The whole country, various sectors, various regions have all seen upticks in heavy precipitation events. This is showing the trend in the highest daily rainfalls, highest 1% of daily rainfalls going back to the 1950s. And it's showing positive trends in all the 6 or 7 different regions. But the farther north you go and the farther east you go, the bigger the increase. So here in the upper Midwest, we're close to the highest nationally. And so Wisconsin is certainly a big part of the recent climate change picture around the country. Now, getting back to that event in August of 2018, I'm sure many of you were around for it and you won't forget it. In just one day, we had almost hurricane-like amounts of rainfall, just unimaginable for Wisconsin. And this is a map that shows the heaviest rainfalls in western Dane County, especially Middleton, but even getting into Madison. And these rainfall amounts are in inches, and they would be impressive snowfall totals. But these were just rainfall totals in one day. And not surprisingly, they caused a huge amount of damage. I think there was about $150 million or more in damage in Dane County, and unfortunately, 1 fatality from floodwaters. And this set an unofficial Wisconsin record for heaviest 24-hour rainfall, set at several different rain gauges. So when these sorts of events happen, they certainly beg the question of whether or how climate change may be playing a role. And so what I'm going to get into now is some stories that happen to me frequently, and I'm sure Dan can relate to this too. When we get one of these extreme weather events, I often get a phone call or an email from a reporter, and the call goes something like this. Dr. Vavros, we'd like your opinion on whether the extreme weather event of the day was caused by climate change. And I always have such a tough time answering that. I usually start with, Like, how am I going to answer this? Because it's an example of an ill-posed question, because the reporter wants a binary yes or no answer to that question, and reality is a lot more subtle and a lot grayer. And it used to be, not that long ago, that when we would get these sorts of questions, we'd have to say something kind of wishy-washy, like, well, we can't attribute any particular weather event to climate change, but it may be consistent with, and nobody's really satisfied with that answer, the giver or the receiver. But since that time, there's been some real advancements in the field, and a cottage industry has developed on extreme weather event attribution. And I'll describe how that's done in the next set of slides. When there's an extreme weather occurrence that makes the news, like this example from Hurricane Harvey from 4 years ago, that really dumped unimaginably large rainfall totals around Houston, over 40 inches in places. People want to know, did the warming climate have anything to do with this? And so what's done with these extreme event attribution studies is something like this. So you consider that event, and then you run 2 climate model simulations. The first one is a hypothetical world that didn't have human-induced climate change. So this is the so-called counterfactual climate that we could be living in today, but we aren't, in which case we would eliminate the Industrial Revolution, for example, set the climate model to be driven by pre-industrial levels of CO2 and methane, run the climate model that way, and then we do a parallel climate run with the same climate model, but this time using actual CO2 and methane concentrations, so a warmer climate. When you run this pair of simulations many times to build up statistics, you can then see how often and how intense an event like Hurricane Harvey occurs in the counterfactual climate and the actual climate simulation. And from that, we can come up with some attribution statements. And these usually run the gamut between discovering that climate change did not actually alter the likelihood of an extreme weather event. That happens sometimes. Sometimes the studies say that climate change has made these events less likely, sometimes more or very much more likely, and occasionally a statement like it could not have happened really without climate change. And in the case of Hurricane Harvey, there were a couple of attribution studies done shortly afterwards. And one of them concluded that the rainfall, or that the event itself, these kind of magnitudes of rainfall, were 3 times more likely as a result of climate change and 15% more intense. Another study found 20 to 40% more intense rainfall. So in both cases, these attribution studies are able to help us address the question of the role of climate change. But even then, they can't and shouldn't try to answer this in binary terms that climate change did or did not cause Hurricane Harvey or any other particular weather event. So around here, getting closer to home, away from southern Texas, we too have certainly gotten wetter and warmer, as I showed before. And if we look a little bit shorter in the record, we can look at the spatial patterns of this warming and wetter trend around the state. This too, I think, are maps that Dan produced, and I'm borrowing here, of annual temperature and annual precipitation like before, but this time we're able to see what it looks like across Wisconsin. And what you see is, since the mid-20th century, the whole state has warmed. The gold is 3 degrees Fahrenheit, the yellow is 2 degrees Fahrenheit. The asterisks mean that these are statistically significant changes in each of the 9 climate divisions, not likely due to chance, but really climate change. But notice it's a fairly uniform warming trend across Wisconsin. For precipitation, we see also that the whole state has changed in the same direction, getting wetter, but now we see more spatial differences. So the north, only about a 5% increase. As you go farther south and farther west, we see bigger increases, all the way up to 20% around Dane County and farther southwest in the state. And only the southern 2/3 of the state has seen a significant precipitation trend since the mid-20th century. But in any event, warmer and wetter, again, the theme here. Now, we can't change the past. Hopefully we can learn from the stress tests we've experienced in recent years. What we really want to know is, where are we headed and what can we do about it if we know, get some sense of the future. Climate model simulations like John pioneered can be used for future, as our future crystal ball, as it were. If you look at global predictions of temperature and precipitation by the end of the century compared to the recent past, not surprisingly, the models indicate that the entire world should warm up. But like the previous animation, not everybody the same amount. Notice the Arctic warming more than the rest of the world. But the stippling indicates that the climate models are in good agreement. So we have a high degree of confidence that the entire world will warm in the next century. You'd expect that from a term like global warming, but you might not know about whether we'll become wetter or drier. And the answer is both. Depending on where you are, particularly the farther north you go, the wetter it's expected to become. But other large parts of the world, shown in the brown, are expected to become drier. In this case, the hatching indicates where the climate models are in best agreement. And if we zoom in on Wisconsin, just from this map, we see a wetter trend presaged here, and that the climate models are in agreement. But these are global models, and what we really like to do is refine these to get a better sense of what will happen across the state. And we can do that within CCR and within Wiki. We produce these expectations, these statistically downscaled climate model predictions. So that's taking into account the geography of Wisconsin, the topography, proximity to the lakes and rivers and so on. And that gives us a much sharper image of what kind of future climate change we're expecting. In this case, temperature, looking at the end of the century compared to the recent past. This is showing the entire state should become much warmer than we've seen, about 6 degrees Fahrenheit in most of Wisconsin and all the way up to 7 degrees in the north for a pretty middle of the road carbon emission scenario for the future. And notice that that's a lot more than the 2 or 3 degrees Fahrenheit that we saw over the past 70 years. And this is a projection for the next 70 years. And to put it into context, it's showing that Madison should become about 6 degrees warmer than recently. And that is like the present day climate of central Illinois. And that is a very big and noticeable climate change that no one could miss if it comes to pass. These are annual conditions. We're expecting slightly greater warming during winter, but fairly similar increases during all seasons. And then finally, precipitation. Also, the whole state expected to change in the same direction, but not by the same magnitude. The south less, a little bit more in the north, but notice that these are only about 5 to 10% increases, which is actually less than the increase we've seen over the last 70 years. So kind of interesting. Maybe we've getting close to the maximum, but these are annual projections, and we know that the models suggest that winter and spring will see bigger increases than this, whereas summer, the climate models disagree with each other. So we have a lot less confidence in how our summer rainfalls will change. Again, though, it's not just the averages that matter, it's the extremes. In this case, I'm showing a projection of extreme heat for 100-degree days. All of us cheeseheads would agree, 100-degree day is hot around here. And mercifully, we rarely have 100-degree heat in Wisconsin. In fact, if you take the long-term average, it's less than 1 day per year. But that's expected to change in the future, as you might expect, and it'll become a fairly common occurrence. Estimated here to be about 2 days per summer in the north and as much as 6 degrees in the far south, Madison going up from an average of 0 to 4. So still just a handful of days, but that's considerable for a long-term average. Do the same exercise for extreme rainfall. In this case, the metric is 4 days or more, counts as the threshold for extreme rainfall. And I'm showing here days per 100 years in which we have these extreme rainfall events. Historically, these happen rarely. In Madison, less than 1 time per year, so 8 times per century. And in the future, the whole state is expected to see an increase. Notice that the pattern is similar between the two maps. So more in the west and the south in the past, same in the future, but the magnitudes go up. And for Madison, going up to about 13 days per century. And if you do this for different parts of the state, you'll find that extreme rainfall is expected to go up in the future about twice as often, twice as common in the future as in the past. So significant. Now again, what can we do about this? Even if the models are correct, and that is our future. It doesn't have to be. It's up to our carbon emission future. But what can we do about this, assuming that climate change will continue in some capacity, even if we can take action on climate change and reduce our carbon emissions? And we attack this in two ways. One is through mitigation, which is trying to nip the problem in the bud. In this case, trying to reduce carbon emissions or draw them down even from the atmosphere once they're up there. And then adaptation, which is accepting that climate change is here. There's going to be more climate change in the future. And how can we cope? How can we make the situation better than it would otherwise be in terms of the impacts that it has? A good example of mitigation is the approach that our new President Biden has taken. He campaigned heavily on climate change as being one of the 4 national crises. And since he took office, he has made a number of plans, including committing the US to net zero carbon emissions over the next 30 years, immediately re-entering the Paris Climate Agreement. He's established 2 brand new cabinet level climate advisor positions, made an emphasis on environmental justice, recognizing the equity that needs to come with any climate change plan, because climate change doesn't affect everyone equally. And if you've been keeping up with the news, this is a big component of the new infrastructure plan. Oh, and I should point out that the state, through Governor Evers, is largely mirroring a lot of that, including the net zero carbon emissions by 2050. An example of mostly adaptation, but also mitigation, is what Dan mentioned earlier, the WICI, the Wisconsin Initiative on Climate Change Impacts. He and I are co-directors of that. This is an effort that's been around for 13 years from the partnership from the Wisconsin DNR and the Nelson Institute. And our purpose, our mission, is really pretty simple. We're trying to generate information that can foster solutions to climate change in Wisconsin. And generally, we've been more about climate adaptation, but we're recently getting into the mitigation world as well. And WICI consists of a lot of different working groups covering topics such as forestry, Great Lakes, human health, tourism, and a dozen or so in total. And that expertise is going to be harnessed into a new assessment report coming in September. So be on the lookout for that. The last one was 10 years ago, and it's high time that we update this. And so be on the lookout for that in the fall. A clear example of adaptation, which is helpful in the present climate and will be even more helpful as we get more heat waves in the future in a warmer climate, are things like heat wave action plans. These are things in this example from the Wisconsin Department of Health Services. They've put together an extreme heat toolkit for public health and community professionals and leaders, so that when we do have a heat wave, we have some guidelines on what we can do to reduce mortality. A lot of these are just common sense things like checking on your vulnerable neighbors and publicizing heat wave warnings and having public cooling centers like we have at the Convention Center in Madison, public libraries. And these have been implemented by a number of cities around the country, and they really are saving lives. Chicago, for example, had the notorious heat wave in 1995, killed over 700 people. 2012, they had a comparably bad one, but fewer than 20 people died, in large part just because the city took heat waves more seriously. And here's an example that's not so relevant for Wisconsin, but in places prone to hurricanes. I plucked this example off the web, and this is from coastal Florida. And this is from a recent hurricane. I think it was Hurricane Michael, a Category 5. And look at the destruction around the coast, except for this one building that was reinforced to supposedly withstand 250 mile-per-hour winds. And it looks like it came out unscathed. The only building around like it, and except for the one that piggybacked, got a free ride behind it from that protection. But there's an example that if you're willing to put in the investment to improve your infrastructure, which can be done, you're in a much better position to withstand extreme events, some of which will become more common with climate change. And then the final example I'll give for adaptation, which is really kind of, I think, sad. This is a geoengineering approach. I don't know if you can make out, these are white tents that are covering glaciers in the Alps. You can see a couple people here for perspective. And it's being done to try to essentially protect and insulate the glaciers from summer sunlight to reduce meltwater and floodwater that hurt downstream communities. Similar steps are being taken to try to preserve Arctic sea ice. And it just shows you where we're at, that we're willing to consider these kind of pie in the sky solutions to try to preserve and adapt to the changing climate and keep from the effects from being worse than they would otherwise be. I'm going to close not with a traditional conclusion slide, but instead a synthesis here of different types of extreme events and how we think they are going to change in the future and what confidence level we have in that kind of projection. And I should give a disclaimer that these are my own opinions. Not all climatologists would necessarily agree. Not even Dan might agree with all of these, but I think they're pretty mainstream. So heavy precipitation events, we talked a lot about that tonight. The warmer atmosphere holds more moisture. So when we do get the right weather conditions for heavy rainfalls, we can expect more. Around Wisconsin, wetter conditions and wetter in winter and spring, the confidence level is high on that. However, for drought, I would say that that's largely uncertain around here. California, probably likely, but around here in summer, the climate models, as I said, disagree on whether we'll become wetter or drier. So I would say the confidence level for drought changes is low. More hot weather can be expected, probably more muggy weather like we've been seeing lately. I would say that's high in the future, although we've been spared of a lot of these really bad heat waves in recent years. Cold weather, you would expect fewer cold waves eventually down the road as the climate warms, but there's a lot of uncertainty in the near term. We had that brutally cold stretch in February this winter, and a couple other 3 winters recently, we've had these so-called polar vortex events that have come down. And so that shows that you can be extremely cold in a warming climate, but eventually the trend toward fewer cold waves, I would say, is high confidence. Snowfall, you'd expect less snowfall probably, perhaps in the winter, at least a higher proportion of winter precipitation being liquid than snow in the future. But it still means that in a warmer, moisture atmosphere, that when we do get some cold days in the winter, there might be more moisture to tap and possibly heavier snowfall events. So I list that confidence level as medium. Ice storms can be extremely destructive. We've had plenty of those in Wisconsin over the years. I would say that probably we'll be seeing more ice storms in the winter compared with snowstorms in the future. That's certainly the case to our south in Illinois and further south, but that hasn't been proven yet. So I put a medium confidence level on it. And then extreme or severe storms like hail, tornado, or those derecho events, we'd really like to know how those are going to change with climate changes in the future. Unfortunately, they're highly uncertain. These are very small scale events, which climate models are really too coarse to resolve. And so despite all of our interest, the confidence level in those is low. And then finally with hurricanes, given what happened last summer, you might think we're going to see more and more hurricanes in the future. The models suggest that may not be true. We may actually see fewer hurricanes, but the ones that do occur are likely to be stronger. So the strong storms become extremely strong is the indication in climate models, and we've seen some examples of that in recent years. So I would say the confidence level for that is medium to high. So I'm going to end the show now and get back to the questions and audience, and be happy now to take questions either that you've submitted already or that you've conjured up as I've been speaking. So thank you for your attention, and I'll be happy to turn it over now to Dan for the Q&A session.
Thanks, Steve. And around Madison right now, there is a virtual round of applause. So it's one of the awkwardnesses of Zoom conferences, but I'm sure I certainly appreciated a lot of what you had to say there. We've had a lot of really good questions in the chat box, and I'm going to start off with one that's a physical science question, and that I thought you would enjoy. What is the summer equivalent of the Arctic vortex, the polar vortex, in terms of dangerously hot events? So in Madison, in Wisconsin and or Illinois, and what would drive an extreme heat event for this area?
Yeah, so an extreme heat event, when we get those, well, we have 2 flavors. We have the hot humid kind, and then we have the hot dry kind. And we've seen examples of both. If you remember back the summer of 1995, we had lots of hot and humid weather. That was the year of the bad Chicago heat wave. But we've also had a recent example in 2012 of a really hot, dry summer. If you remember that, all of our lawns turned brown and nearly died. And so we have both types. The hot, dry kind typically occur when we have a really slow moving weather pattern and things get locked in. We get a lot of subtropical air that just parks here in the summer, and it lasts for a long time. And the positive feedbacks kick in, the soil moisture dries out. And so we basically bake, and that's when we're prone to the 100-degree days. In fact, I think the last time we hit 100 around Madison was 2012 during that dry stretch. So the concern with climate change is if we get slower moving weather patterns and the jet stream slows down in the summer, and there's indications that it has and that it may continue to, that would promote heat waves. So they typically happen when we get these prolonged periods of hot and often dry weather.
Thanks, Steve. Another question from, I believe, Ashley. How might you suggest talking about extreme weather events and relating them to climate change to family or friends who are skeptical of the climate crisis?
Well, depending on how much depth you want to go into, you could summarize what I described about those attribution studies and say that, you know, we're at the point now when we can actually make quantitative assessments and say, you know, some event like that cold wave we had in February was X% more likely or less likely because of climate change. And we can talk about these events in really quantitative terms. But another thing is to bring it into the physical realm and just say, based on really simple meteorology, like the fact that a warmer climate, warmer atmosphere can simply hold more moisture. That's a physical fact. And so even if we get the same weather patterns and cold fronts in the future, if you can wring out more moisture from the atmosphere, it stands to reason that the heavy rainfall events will become even heavier in the future. And I think that the simpler you can make the argument physically, probably the more convincing it is.
Thanks, Steve. We had a couple questions about mitigation. One of them, are any of the proposed mitigation strategies that are out there enough? And then the other one that we had was, what are a couple of the top actionable changes that individuals, families, communities might be able to take in the next 2 or 3 decades?
Yeah, so the mitigation plans, even the Paris Climate Agreement is not enough. And I think all the experts would agree, even that's not enough. You know, movement toward a carbon neutral economy in 30 years is really ambitious. It is the sort of steps we need to take at the state and national, even international level. Whether that comes to pass remains to be seen. You know, promises are easy, follow through is difficult, but that's the scale, I think, that we're talking about needing to take. And the Paris Climate Agreement and things like it were designed to be opening steps to get the international community working together and then to follow it up with something more substantial. In terms of steps like individuals and communities and so on, one source I recommend is Project Drawdown, which you can get online. This is a quantitative analysis that was done by scientists and policymakers to try to prioritize different steps we can take to reduce carbon emissions. And for example, the top recommendation for them was managing refrigerants, of all things. So the hydrofluorocarbon coolants that are in refrigerators and air conditioners, if those leak from improper disposal, they get into the atmosphere and they trap heat, and they're extremely, surprisingly powerful greenhouse gases. So at a broad level, international agreements can tackle that. At an individual level, there's all sorts of things we all know we can do: drive less, drive more fuel efficient cars, more fuel efficient appliances. But a couple that maybe not come to mind, one of which is vote. We know climate positions for most candidates. And the other one is food waste. It's turned out that food waste is one of the biggest carbon emitters, surprisingly so. And nobody wants to waste food. It's bad for our pocketbooks, it's bad for the climate, and it's also bad for your health if you eat spoiled food. So it's a win-win if we try to cut down on food waste. And so that's one that is really below the radar, I think, as a climate change solution.
Thanks, Steve. I put the link to Project Drawdown in the chat if anyone has questions. And while we're at it, if you have questions, feel free and post them in the chat. There are a few there, and we're going to get to some more of them in just a second. If you're unable to figure that out, just scroll to the bottom of your screen, and there should be a chat button down there, and then that'll open a window for you to type there. Also, if you would like to, if you're having trouble with that, there is a raise hand issue, and I'd be happy to, we might be able to unmute. I'm not sure if that would work or not. Another question for you, Steve. What are some of the things that are happening here in Wisconsin? Some examples of specific adaptation events or adaptation activities or things that people are doing to prepare for the expected consequences of climate change?
Yeah, so one thing that's happened just in the past couple of years are some executive orders from Governor Evers. One was to establish the Governor's Task Force on Climate Change, which has been in the news quite a bit. And they have recently sent the governor a set of recommendations, and on like about 50 recommendations on mitigation and adaptation steps. And some of those have actually been incorporated into his budget. I understand that there's quite a few components in there, things like green infrastructure, restoring wetlands, more traditional infrastructure with roads and bridges to make a more climate resilient infrastructure for electric vehicles, having more recharging stations, for example, support for farmers who were impacted by extreme weather, and so forth. And another executive order was creating the Office of Sustainability and Clean Energy, and they are tasked with trying to reduce Wisconsin's carbon emissions to net zero by 2050, mirroring the national plan.
Thanks. There's a lot of good questions in the chat here. I'm going to go back to another one here. What is the impact of climate change on health? Lisa Drummond is asking, does climate change contribute to issues such as pandemics, including SARS or COVID, what we're experiencing right now, as well as what other health impacts might we see?
Right. So our colleague Jonathan Patz on campus, and who's an MD as well as a scientist studying climate change, has done a lot of work on this. And one of the ways in which climate change affects health directly is heat stress during the summer. As I showed, it kills more Americans than any other type of weather event. Also waterborne disease, when we get these heavy flooding events and washing off pollutants into rivers and lakes and beaches, closing beaches, that certainly affects human health. In terms of the pandemic, he's done some work indicating that there is a parallel, and that is that one of the reasons he thinks the pandemics are more likely now is because the animals that transmit them, say bats, for example, are coming more closely into contact with humans as we destroy their habitat. And so destruction of the natural world could potentially make a pandemic more likely. And certainly our industrial activities are certainly making climate change more likely. But at the same time, he talks about the co-benefits of addressing climate change and helping our health. For example, switching toward less meat eating, toward more a plant-based diet is healthier and better for the climate. Taking fewer trips by car, short trips, if you can do it by bicycle or walking, is better for your health. And we also know that pollutants, say from smokestacks and car exhaust, not only produces invisible carbon emissions through CO2, but also visible pollutants like black soot and particulates, and those contribute to asthma. So if we clean up the atmosphere, we can have the co-benefit of healthier breathing, cleaner air, higher air quality, while we tackle climate change at the same time.
Thanks, Steve. Kurt Johnson is asking about permafrost in the Arctic and Arctic processes that may contribute to greenhouse gases to the atmosphere. And asking for information on that.
Yeah, well, it's a good point. There's a lot of carbon locked up in the permafrost and the boreal forests. I mean, much more so than we even have in the atmosphere. So there's a legitimate concern that as the climate warms, if the permafrost thaws and some of that carbon, it's in the form of methane, escapes and gets into the atmosphere, that could trigger a real enhanced warming in the Arctic, even more than we expect today, and affect the magnitude of global warming at the same time. So that is a real concern, and a lot of people are studying it. Surprisingly, though, I think the jury's still out on that, because intuitively you would think, well, if there's a lot of carbon in the soil and the soil is thawing and releasing it to the air, that's got to warm things a lot. But it turns out it's more complicated than that, and not all that carbon escapes into the air. Some of it's eaten by microbes, some of it's released in lakes, doesn't make it to the surface. So a lot more work needs to be done on this, but it's definitely a big wild card, and boy, that would really change the equation in a big way if that becomes a significant source of carbon emissions in the future, that being a thawing permafrost.
That's a great, Steve's bringing up a really great, and Steve is the right person to ask about this. Steve is part of a growing group of polar researchers on campus, and we've just, in CCR, put on my CCR hat for a moment, CCR helped lead a project to hire new faculty in understanding the changing polar regions. So that's a great question.
And Dan headed that effort. He wouldn't take credit for it, but I'll give him credit because that was his impetus. So that was a big contribution, and that'll really help our polar studies on campus for years to come.
Such an important
research. So. That's their organization.
Yeah. One other question that we had up here, can you say anything about Lake Michigan lake levels and variations in Lake Michigan lake levels with climate change? What's happened in the past, and do we expect continued trends in the future?
I can say a lot about it. The most is that we don't know what's going to happen. And I'm not an expert on this, but I've talked and listened to experts, and they conclude that as much as we'd like to know, it's really hard to say. What we do know is that there's been some real big fluctuations recently, and that may be the reason the question was asked. I think it was as recently as like 2013, Lake Michigan was really, really low. And then in a couple of years, in the last 2 years, it's been at record highs. So that's a huge range and within a decade. But it's hard to say what that holds for the future because what matters for lake levels is how much precipitation comes down, how much runoff there is, and how much evaporation there is off the lake. So precipitation and runoff raise lake levels, evaporation lowers it. And what's expected in the future is that all three of those terms will increase. And so when you're talking about the difference of two terms and they're both increasing, it's really hard to say what the sign of the change will be. And so I think that definitely there's a lot more research that needs to be done to figure out that question, but it's a very practical one, particularly for people who own property along the lakeshore.
So that's a great question. We had one other question here. I guess before we do that, there are a number of comments in the chat asking whether the presentation will be available, and I believe Todd put a link in the chat to that, and also it will be listed on Bethel Lutheran's website. And Todd, I'll maybe after Steve addresses the questions, you can update that. We've also put links to the wiki website, www.wicci.wisc.edu, and their climate maps are available and a lot of additional information. And so Steve is a co-chair of that, and a lot of this information is there as well. There was a question, and I guess this is perhaps the last one that I saw here. How do we deal with climate skeptics? Are they part of the problem, or that it was worded very well? Let me grab this specifically because, oh yeah, Barry Sherlock asks, are climate skeptics likely to be significant parts of the problem or mainly unlikely to be significant parts of the solution? Or unlikely to be significant parts of the solution, i.e. how much does it matter to spend energy helping to acknowledge climate change realities?
It's a great question. You'll probably get different answers from different climatologists. I would answer it, I think it depends on who the skeptic is and what they're talking about. In other words, what level of the debate are they engaged in? If somebody's doubtful that the climate's been warming and thinks that we have no idea what's going to happen in the future, I would say it's probably not worth your time. I don't think you're going to change any minds in that case. But if they say, well, the climate's warming, we're going to have to deal with it, but how is the Arctic affecting the circulation and our extreme weather in this part of the world? I think those are very much open science questions. So when people say, is the science settled or not? I think the science is settled on some points, but not other points. So I think it depends. I think you have to kind of feel the person out for what level they're at and whether they're open-minded on some of this and closed-minded on others. But in terms of outright complete deniers, I think they're fewer and farther between now than they used to be even 10 years ago. I mean, when you have record-setting heat year after year, it becomes harder and harder to take that position.
It's interesting to hear your response. I was curious to hear what your response on that was, Steve, and that's been my experience as well. That the conversation has changed quite a bit in the last decade, I think.
Mm-hmm.
I think that wraps up the questions that we have in the chat. And we're at about an hour. Todd, I'll turn it back over to you.
Well, thank you, Dan, and thank you, Steve, for a lively Q&A session as well as an outstanding presentation. Yep, we're at the end of our time, and so thanks to everyone who has joined us, especially for those excellent questions and comments that we've been discussing. We hope you found this time interesting and informative. I want to thank especially Ashley Becker and Rob Colehep behind the scenes for their technical support. And once again, our speaker, Steve Vavros, and Dan Plymont for stepping in to chair the event tonight. And as we were just alluding to a few moments ago, this event has been recorded. It will be posted probably within this week on the Caring for Creation page on Bethel's website, www.bethel-madison.org/C4C. That's our nifty abbreviation. And I want to add that just before we close, that Bethel is currently planning an exciting series of events on the theme of environmental stewardship throughout the month of July, including Bethel's investments in solar energy. These will include celebratory in-person events on Sundays, COVID permitting, as well as podcasts and virtual events during the week. So watch your email, the Bethel Daily Devotion, the Bethel Light, and the Bethel website for more information. And please invite your friends and family to join our future events. And until then, good night, and may good health and the peace of God be with us all.
Thank you.